Okay, so today we're taking a look at how to factor trinomials. So a trinomial is a three-term polynomial. The last couple of notes we've been focusing on binomials, and we looked at the special binomials like difference of cubes or sum and difference of, no, difference of squares, and then sum and difference of cubes as well. So today we're moving on to a three-term polynomial, which is called a trinomial. So let's begin with what I have in box one. And we're going to spend a couple days on this, by the way. So today is kind of an introduction into it. And then to the next time we meet, we will look at a little bit more complex trinomials. So today, these are going to feel somewhat simple, and hopefully that'll be a good thing. So if you look at the first box, what I have here is almost like a reference, like a cheat code in a way. It's for you to reference like when to use certain signs. Okay, now this will become more natural as we start doing the problems, but this is always something you can refer back to. The biggest one to remember here is that whenever you have a polynomial that has two plus signs, it'll factor into two binomials that has two plus signs. Okay, when you have a polynomial that has a positive c but a negative b, they're both going to be negative. Okay, and you'll see why. And that's because usually we'll need two numbers that multiply to be positive but add up to be a negative. The only time that happens is when you have two negative numbers. Two negative numbers will multiply, be a positive, but add up to be a negative number. Okay, and then you have these two situations where you could have a negative b and a negative c, or a positive b and a negative c. And in this case, it just means that one term will be positive, one term will be negative. It doesn't always mean that the first term is positive and the second term is always negative. It's just that you're going to have one of each, one positive, one negative. Okay, and that's because we're focusing on C. If C is negative, that means that it had to be a positive times a negative, right? There's no other way to get a negative number unless you multiply one positive with one negative. If they're both negative, you could get a positive C. If they're both positive, you could get a positive C, right? So the last two, the bottom two, just show us to get a negative C, you would need a positive term times a negative term, okay? So this is just to refer back to if you need it, okay? But I think that the way that we'll go through the notes, you'll be able to kind of intuitively understand how to find the numbers and the factors that you need. All right, so we're going to factor this polynomial. We have x squared plus 11x plus 18, okay? Whenever you do factoring of a polynomial and a trinomial, it's basically a two-part question. The first part of the question is I need numbers that multiply to be positive 18, and I need them to add up to be a positive 11. Okay, so essentially what we're doing is, and what I like to do is create like a little T table. Where I need to satisfy several requirements. So I need them to a product, to give me a product of 18, right? So I need two numbers that will give me a product of 18, but will sum to 11, right? And where am I getting those numbers from? Well, I'm looking at my constant, which is C, right? I need the numbers to multiply to be this constant, which is positive 18, but I also need them to add up to be 11. So the numbers that I choose have to satisfy both requirements. Okay, so let me give you an example of one that is clearly wrong. A product of 18 could be 1 times 18, right? But when I add those numbers up, they add up to 19. So that's clearly not the option that I'm looking for. Okay, so what combination, what factors of 18 also add up to be 11? Yeah, 9 and 2, right? If you think of 9 times 2, well, they also add up to be positive 11, so that works out. Okay, you could have tried 6 and 3, but 6 plus 3 only adds up to be 9. Okay, so your goal is what numbers multiply to be the last number, 18, but add up to be the middle number. Okay, and so here's how we're going to factor this. We have our two binomials. The easiest part is always here. How do I get x squared? What needs to be multiplied together to get x squared? X times x. And guess where x is going to go? In the front of both binomials, right? Because x times x gives us x squared. Okay. So now, the winning factors were 9 and 2, right? Positive 9 and positive 2. So I'm going to use positive 9 and positive 2. Okay. And this would be my factorization. Okay. I can easily see, right? Check this out. X times X multiplies to be X squared. Positive 9, positive 2 multiplies to be 18. So the only thing I still need to check for is make sure that they do add up to be 11. Okay, they have to add up to be 11x. So how do I test for that? Well, I'm going to apply kind of like this happy face method. All right, at least that's what I call it. It's my method, where I'm only testing to make sure that the two middle terms of the polynomial will add up to be 11x. So how do I test for that? Well, I'm going to multiply 9 times x to get 9x. X times 2 at the positive 2x. Okay, so these are both positive. When I add them up, I get 11x, right? That checks out because that's what the middle term is that I'm supposed to get back. Okay, so this is a quicker way of testing rather than you having to distribute and check all four terms to make sure that it eventually gives you the x squared plus 11x plus 18. Okay, you basically check what are my two front terms. Those would get multiplied together. They give me x squared. We're good. What are my two actual factors, 9 and 2, positive 9, positive 2? Those multiply together. If I were to multiply them, I would get positive 18. So then what you're only looking for to verify is the middle term, 11x. Make sure that you do add these numbers, that these numbers add up to be 11x. And in this case, they do. So when you do that, you can legitimately say these would be my two factors, x plus 9 and x plus 2. Okay. Any questions there on example 1? So a lot of times what you're doing is just like hunting for numbers. Like I'm hunting for numbers that do this and do this, right? They multiply to this and add up to be this. And typically you never really have to think about the x squared because you know that the only way to get that is to have x times x. So that's where you would have x at the front of both of the binomials. Okay, let's move on to another example. Okay, kind of similar. All right, so as you're getting used to the process, make a little t-table. You want them to be a product of 14, but sum to be 9. Okay. Can you think of a combination of numbers that could do that? Yeah, there you go, right? So a positive 7 times a positive 2 multiplies to be 14, and it also adds up to be 9. Okay. So guess what? We're going to factor. Once again, the only way for me to get x squared is to have x times x. That's almost always the easiest part of the factoring process. You don't even really have to think about it. All right. The next part is using the numbers that you found, the two factors, right? It's a positive 7 and it's also a positive 2. Okay. So you're just going to run through the test real quick, right? You can do these visually. X times x gives me the x squared. Test the factors. 7 times 2, positive 7 times positive 2 gives us positive 14. Okay. The last part you need to do, test for the middle term 9x. We got to make sure that these will add up to be 9x. So 7 times x gives you positive 7x. X times 2 is a positive 2x. So when they add together, right, you add them together, you get 9x. So that checks out. So you know that this will be the factored version of x squared plus 9x plus 14. Okay, not too bad, right? Okay, let's move on to example 3. Okay. So here's what we want to do now. Another t-table. I want my product to be positive 8, but I want the sum of the numbers to be negative 6. So think about it. I need to multiply two numbers together. When I multiply them, they will be a positive number. But if I were to add the numbers together, they add up to be a negative number. Yeah, right? So you got to think of some negative factors, right? Negative factors. So negative factors such as negative 4 times negative 2, negative 4 times negative 2 is positive 8. If I were to take negative 4 plus negative 2, that will give me negative 6. Okay, so that combination works, right? Here is why the positive 4 and positive 6 would not work. I'm sorry, positive 4 and positive 2 would not work. They multiply to give you positive 8, but they add up to be a positive 6, so that does not work, right? It has to give you the sum of the term that's in the middle, right? So the signs absolutely matter, okay? The sign matters so much, okay? So let's factor this. What's the only way I'm going to get n squared? There you go, n times n. So you fill in, okay? It won't be n minus 4. It will just be whatever factor you have. So the factor is negative 4, so it's n minus 4. What's the other factor? Negative 2, so then it'll be n minus 2. Okay, it's not minus the factor. It's just whatever that factor happens to be. Okay, if it was a positive 4, it would have been plus 4. If it's a minus 4, it's just minus 4. Okay, so we test real quick. Oops, wrong color. N times n squared. Easy. Negative 4 times negative 2, positive 8. Now we do double happy face. We want to check that these two terms will add up to be negative 6n. Okay, so negative 4 times n, negative 4n. Negative 2 times n, negative 2n. Add them up. Negative 4 plus negative 2n, negative 6n. That checks out. Okay, any questions there? Okay, next one. What is it that we're looking for here? What would we like our factors to be able to do? That's right. We want a product of 12 and a sum of negative 8. Okay, product, we want product of 12, sum of negative 8. Okay, what are some options? What do you think? Yeah, we can have a negative 2 and negative 6. Let me use a different color actually. So negative 2 and negative 6. These will multiply to be positive 12. Oh, wait a minute. I put the wrong number here. This should be the sum of negative 8. Okay. And they will add up to be a negative 8, right? So that checks out. So let's go ahead and factor. In order to get y squared, we need to use y times y. Okay, what are my two factors? Well, my two factors are -2 and -6. So it's just a direct copy paste. So you'll have y minus 2 and y minus 6. Those will be my two factors. So we'll do a real quick eyeball test. Y times y, we get y squared. -2 times -6, positive 12. So all we do now is test for the middle term. -2 times y is -2y. Y times -6 is -6y. And then when you add the terms, you get -8y. That checks out. That's what we want. So this is my factored form of the polynomial. Any questions so far on example 4? All right, good. Cool. All right, let's try now number 5. Okay, example number 5. Can somebody tell me what combination are we looking for? What do we want the combination of factors to be able to do? Okay, so product of -20, good. And where'd you get 1 from? Yeah, it's 1m, right? The m has no coefficient in front of it. So if there is no coefficient, that means that it's an invisible 1. So we want the terms or the factors to multiply to be -20, but add up to be a positive 1. Okay, so we want the sum of 1. Okay. So let's think. I'm going to multiply two numbers that the product of those two numbers must be negative. Okay. And what does that tell you? If I'm going to multiply two numbers and then the answer is negative, that means one of the factors must be negative, right? So Luis is helping us out here. The product of 5 times -4, right, gives us a product of -20. And if I were to add 5 with -4, it gives me positive 1. Okay. Notice how it works here, but the opposite does not, right? What if you tried -5 times 4, right? Why does this combination not work for us? It multiplies to be -20, but what's the sum? The sum would be -1, right? That's not what we want. We want positive 1, right? That's why the sign is so important. Okay, so we know that the first set of factors is the correct one, the second one is incorrect. So let's go ahead and factor. Only way to get m squared has to be m times n. My two factors, 5, that's a positive number, so it's m plus 5. Other factor, -4, so it's just m minus 4. So quick double check, m times m squared. 5 times -4, multiply them, -20. That's good. Lastly, double happy face check, all right? 5 times m, positive 5m. M times -4, -4m. Okay, you can add them, or you can just see how that just ends up being 5 minus 4. 5 minus 4m is just positive 1m. That checks out. So my factorization is m plus 5 times m minus 4. Okay, how do we feel about 5? The same? Good, okay. So like I said, it's just a manipulation of basic factors, basic numbers, right? Multiply to be this, add up to be this. That's it. That's all you have to think about. Okay. How about you guys try 6? And then I will check in with you guys in about 3 minutes. Okay, go ahead and try it. Okay, so here we have the scenario where we're looking for product of negative 48. And we want the sum to be positive 8. So what combination of factors gave you that? Okay, so 12, positive 12 times a negative 4. All right, that looks good, right? We multiplied both of those factors, we get negative 48. If we add the factors together, we get positive 8. Okay, so that's good. So now we get to factor. We know that x squared, the only way to get that is to have x times x. And then we're just going to use the two factors that we found. So the first factor is positive 12. The second factor is minus 4. Okay, so quick visual test. X times x, we get x squared, satisfied that part. 12 times negative 4, multiply those two, negative 48, right? We satisfied that part. And then finally, happy face here, let's go ahead and check. 12 times x is 12x. X times 4, I'm sorry, x times negative 4 is negative 4x. Okay, you can see how this just ends up being 12 minus 4x, so we get 8x. So that checks out, that's the term that we were looking for. Okay, any questions on number 6? Okay. All right, number 7. What is it that we're looking for here? Okay, so we need a product of a negative 18, sum of 7 or sum of negative 7? Yeah, sum of negative 7, right? Always be sure to consider the sign. Okay, so what ideas come to mind? What factors could work for this? Yeah, looks like negative 9 times positive 2, right? Negative 9 times positive 2 gives us negative 18. If we add negative 9 plus 2, we still get negative 7. Right, so that combination looks like it's going to work for us. So let's open up the factors. Only way to get y squared is to do y times y. We're going to use our factor. That's minus 9. Other factor, positive 2. Okay, so quick eyeball test. Y times y squared. Got that. Negative 9, positive 2 multiplies to be negative 18. And now we just double check that they are going to add up to be our middle term. So negative 9 times y, and then negative 9y. Y times positive 2, positive 2y. So negative 9y plus 2y still gives us negative 7y. So that checks out. That's the term that we were looking for. So this is our final factorization. Okay. So far, so good, right? Not too bad. Okay. Number 8. What are we looking for? So we want a product of positive 1, but the sum of yeah, it'd be -1, right? There's no coefficient in front of this middle x, so it's -1x, right? So we want the sum to be -1. Okay, now start thinking, what combination of factors could give us the product of 1, but the sum of -1? So somebody says none. Okay, let's go with that. The only ways to get a product of positive 1 is to be 1 times 1, right? Positive 1 times positive 1. But when you add 1 and 1, don't you get 2? So that can't work. What's the other possibility for us to get a product of positive 1? It would have to be -1 times -1. But when you add -1 plus -1, what do you get? You get -2. No, you can't use decimals. They have to be whole numbers. They have to be integers. And even if you tried, it wouldn't factor. Okay, so sometimes you'll arrive at these polynomials where you've tried all of the different options. Okay, now somebody mentioned, what if you tried multiplying 1 times -1? Well, 1 times -1, the product of that, first of all, would not be positive 1. That would be a product to give you -1. So right away, like this combination, this last combination doesn't even satisfy the first one. And then in addition to that, you can see how if you were to add them up, the sum would be 0. So then both of these, right, they're not satisfying the requirements that we're looking for, right? And that's because there is no way to have two numbers multiply to be 1, but also add up to be -1 at the same time. So what happens when we can't factor the polynomial? What do we say? Yeah, this is a prime, right? Because you've exhausted your options. These two were your only options. This one was never a valid option because it never actually satisfied the product of positive 1. So then when you run out of options, you exhaust all your options. This is what we call a prime. So it's a polynomial that cannot be factored. It is already in its simplest form. Okay. Now, some of the favorite things that students like to do is they try to factor a polynomial and they can't figure it out after one try. So then they go and they say it's prime. Prime is your last resort, okay? Or last resort. Do not call it prime just because you couldn't get it on the first try. You have to try all of the different options before you can say prime. So most of the time, polynomials are factorable. Almost most of the time, they're factorable, okay? Very few times will we throw something at you that is a prime. So if you find yourself calling every polynomial a prime, you got to try a couple more times, okay? It's probably there. You just maybe haven't thought of the right combination. Okay, in this case, we had to try a couple times, right? And then we arrived at, oh, well, there's nothing that really works. So then we can call it a prime. Okay. So use prime sparingly, okay? All right, number 9. Okay, we've talked about different ways to factor. And when we do factor, there's always a particular thing you need to look for at the very beginning because it might make things much simpler as you move forward. Right? What is that type of factoring called? What is it the one that you should always be looking for first? Yeah, it's a GCF, right? It's a GCF because this looks pretty intense, right? This does not look as simple as the ones that we have done all before. That's probably because there's something that could be factored out of all three terms. And once we do that, maybe then it becomes a little bit easier to see. So what is the GCF here between the three terms? What can they all be divided by? All right, looks like they're all divisible by 5, right? Anything else besides 5 that they all have in common? No, there isn't. I'm just double checking, okay? Because I noticed how 2 of the terms have x, but the third one doesn't, right? So the first term has x, the second term has x, but the last one does not. So x is not a common term. The middle term and the second term both have y, but the first one doesn't. Okay, so always kind of look carefully at what they do have, what they don't have. All right, so it seems like the only common factor that they have is 5. So we're going to factor out a 5 to start. We factor out the 5. What are we left with? Right, 5 divided by 5 will cancel. We're left with x squared plus 65 divided by 5. What do we get? Yeah, it looks like we get 13xy plus 200 divided by 5. What do we get there? All right, we get 40y squared. Okay, so now notice how there's multiple variables in play, right? There's x squared, there's xy, there's y squared. The variables will kind of take care of themselves. Let's still focus on the actual values. Let's focus on the factors. Okay, what is it that we're looking for? What are we trying to find? Yeah, we want a product of 40, but a sum of 13. Okay, and can you think of factors that will give you a product of 40, but add up to be 13 as well? All right, good, right? Looks like 8 and 5 or 5 and 8, right? Both of them positive, right? Positive 5, positive 8. Product to be positive 40. They also add up to be 13. That looks good. Okay, so now the question is, okay, I need them to multiply not just to 40, but to 40y squared, right? So if it's to 40y squared, then all that really changes is, well, this has to be 8y and this has to be 5y, right? Because 8 times 5 is 40. How do I get it to be y squared? Well, they both need a y. Y times y will give us 40y squared, okay? The 13xy will take care of itself, okay? So watch this. We're going to open up the factors. In order to get x squared, right, the only way that that factors is to have x times x. Okay. In order to get the 40y squared, the positive 40y squared, we needed the factors positive 8y and positive 5y. Okay. And maybe you can see how the 13xy comes to be, right? Because now we're going to double check to make sure that those middle terms add up to be 13xy. So when you apply double happy face, you get 8y times x. So what's another way of saying that? That's 8xy. Oops, why did that move? When you multiply x, sorry, I don't know why it keeps moving. X times 5y. That's a positive 5xy, right? So multiplying them is what's going to allow you to get that term xy. Okay, so it's 8xy plus 5xy. So guess what? We arrive at the 13xy. We're allowed to add them, right? Because they're like terms. They both have xy, so we can combine them. Okay, so this checks out. We get 13xy. So you see how the first two factors, that's how you arrive at the x squared. The second two factors, 8y and 5y, that's how you get the 40y squared, okay? The product of them, right, when you start to distribute is gonna take care of itself, all right? So that's how you arrive at the 13xy. So you really only ever have to focus on the two, on the corners basically, right? Like how do I get the front? How do I get the back? The middle will take care of itself. Okay, so that's why here in your factors, you only have x and x, you only have y and y, and then the product of them together eventually works itself out. What am I forgetting to bring down? 5, right? 5 was always part of the original polynomial. We would not have the same polynomial if we did not bring down the 5. So bring down the 5, and then we've arrived at the final expression. Okay, so a little bit of a tougher problem for sure. So this is where you have to start using multiple methods. Look for a GCF, right? On a trinomial this time. Once that GCF is out, it doesn't mean I can just stop. I have to then look to see, okay, can I factor the trinomial now? Not necessarily. Remember that multiplication is commutative, right? So the products can kind of be rearranged. No, you'll still get the same outcome. Okay, and let's take a look at the last two here with number 10. All right, so we learned something about this. If you look at number 10, something should stand out to you, something that just doesn't seem right about it. Do you remember? We talked about this during the GCF lesson. Yeah, what about it? So I have a leading term with a negative, right? Imagine that this is like negative 1x squared. So I have x squared, and then the coefficient in front of x squared is a negative 1. Okay. Now, remember that there's a convention in math that we do not want the leading term to be negative. Okay, here's one of those reasons. If we tried to factor this with a leading negative, we would have a hard time. Okay, there would be too many signs for us to keep track of. So we simplify our life, okay, by factoring out a negative if the leading term is a negative. Now, they might not have anything else in common, but at the very least, we can factor out the negative. Okay, so let's do that. We're going to divide every term by a negative 1. So we will get negative 1 times, now this just gives us positive x squared. 9 divided by negative 1 will be negative 9xy. Negative divided by negative will be a positive 18y squared. Okay, we have the negative 1 removed. It's been factored. Now we can focus on just factoring the trinomial, right? So I'm looking at this trinomial. What is the goal? What am I trying to accomplish? What kind of factors am I looking for? Correct. We want the product of 18, right? Let's just focus on 18 first so we get the numbers right, and then we'll worry about the y squared part. And we want them to be a sum of -9. Okay, so for now, I'm not worried about the variables. I just need to make sure I get those factors correctly, right? The actual integers. What combination of factors will give us a product of 18 and then add up to be -9? 6 and 3 would add up to be, remember that my sum needs to be -9. So 6 and 3 as is would not be the correct factors, right? We would need -6 times -3. Okay, so you have to start thinking in positive and negative all the time. Okay, these would add up to be -9, right? So those seems like the correct factors. So if the product is supposed to be 18y squared, the only change I need to make is, well, once I have those factors figured out correctly, it's -6y times -3y, right? That's it. That's the only change I need to make. Remember that the xy, the middle term, will take care of itself, okay? So let's go ahead and factor. In order to get x squared, see how easy it is to just think, how do I get x squared? X times x. As opposed to, how do I get -x squared? One has to be positive, one has to be negative, right? Like now you have to start thinking about signs for the first term as well. So by factoring out that negative, you always get to deal with positive integers for the first term. If the negative had stayed, now you have to start thinking, oh, I need a negative and a positive. Then I got to think about my other signs more carefully so that they add up to be -9. It becomes more difficult. So this is why factoring out the leading negative is an effective process. It's already out there. You don't have to worry about it. Now you can just focus on x times x is what gives me x squared. And I don't have to worry about 1x being positive and 1x being negative. Okay. That's the reason behind the madness, I guess. All right, now let's focus on the factors. I have a factor that's -6y. Then I have a factor that's -3y. Okay, quick eye test, x times x, right? So what I mean by quick eye test is like you look at your paper and that's what you're trying to track. X times x gives me x squared. Got that. -6y times -3y, positive 18y squared. Got that. Now we just double check, make sure that these two terms will add up to be the -9xy. Okay, so -6y times x, that will be -6xy. X times -3y will be -3xy. If I add these two terms, -6xy and -3xy adds up to be -9xy. So that checks out to be the middle term I was looking for. Okay, before I box this, what do I need to bring down? Correct. Bring down the -1. Okay. So now I have my fully factored form. Oops. Didn't mean to chop that negative. And there we go. Questions on number 10. Okay. And now number 11, I leave to you as a challenge. Okay. And we could possibly go over before you take your quiz on Thursday. Okay. So I leave this to you as a challenge. Have it in your notes. Attempt it, right? Try it out. I know some of you like to take on these challenges, and then we will see what you get. Okay. So